Okay, so my name is Roberto Barbera. I'm from the University of Catania and the Italian National Institute of Nuclear Physics. I'm the technical coordinator of the CHAIN project. CHAIN is a project co-funded by the European Commission under the 7th Framework Program, and it aims at homogenizing the different regional infrastructures that have been built in the world and try to create a common way of interacting with EGI. One of the goals of CHAIN is to demonstrate interoperability among the different middleware which are installed on the regional infrastructures we are supporting. So we have developed, based on the SAGA standards, a science gateway that can allow people to submit applications, to submit jobs to different infrastructures surrounding different middleware. And this is the first time we cope with so many middlewares and so many infrastructures. SAGA is a standard, actually. We are using JSAGA, the Java implementation of SAGA, which is developed at the Computing Center in Lyon, in France. And we built on top of JSAGA, we are building what we call a grid engine, a series of an API to interact with the applications independently of the middleware, because SAGA takes care of the different specificities of the different middleware. You can see here in the map. So basically the map shows the sites where jobs submitted through this portal are running, and you see in the different colors different middleware which we are using. So in principle, users can submit jobs to any of these infrastructures. So basically you can widen very much the scope of the infrastructure that a single user can use. Because what matters for users in the end is that they want to run their application in as many places as they can. So independently of the middleware that could act as a barrier between infrastructure and infrastructure. So in this way, with this interoperability demo, we remove this barrier, and we can let users to run everywhere they are authorized to run. You can, at the moment, we are selecting a few virtual organizations, EGI virtual organization, plus some sites running different middlewares in China, in India, in Brazil. And we also have an unicorn site here, the black one behind the green ones. But we could expand, we could run on other infrastructures, because basically we are not using personal certificates, but we are using robot certificates. In the sense that we pre-installed robot certificates in different infrastructures, and the users do not need to have personal certificates to run. So they just need to get authenticated and authorized. Authentication is managed by the SAML standard, the Federated Identity Services. We have an identity federation using the shibboleth implementation of the SAML standard, and the users can access using the credentials they already have. So basically in this way, the entire grid can become a service provider of an identity federation. Basically, for this demo, we prepared a few applications. You can see here. You can see here the applications. These are the demonstrative applications that we selected. Some of them are shipped with the job. Some others are pre-installed, so that we can just send the input files of the job. And then we have applications from arts and humanities. We have biomedical applications, very well known, like GROMACS. We have general purpose applications like Octave and R, which are very well known in mathematics and statistical analysis. At the moment, these applications are just meant for demonstrative purposes, but in the rest of the CHAIN program, we aim to put these applications at disposal of users in the different continents, so that they can run really they can do some research work, because the applications are already true applications. So it's just a question of letting them know that they can run everywhere. This is the first occasion where this demo is out, but starting from next week, we are going to transform this demo in a real service. So if a new infrastructure wants to federate their own resources with them, then either the JSAG adapter exists, and then we include these JSAG adapters in our grid engine, or it doesn't. In this case, with some middleware developers of the new infrastructure, we can easily set up and quickly set up the JSAG adapters, and then the jobs can run on the infrastructure. Actually, this is what we did with this demo. In the case of GOS and in the case of our grid, the JSAG adapters were built from scratch, were not existing before, while in the case of Garuda, which is based on an extension of the Globus, we just modified the adapter, and for Unicore we are a little bit modified for parallel applications. They can use the federated credentials if they have. If not, we can even let them to access the infrastructure using the social credentials, so the credentials they have with the social networks. We transformed the entire Science Gateway as a Facebook applications, and we plan to do the same with other kind of social networks. This application page here, this is a Facebook page for the community of the chain Science Gateway, the one that we built for the demo. And in this page, I mean, you can have usual information of a Facebook page. The interesting is that you can go to app, and then if you click go to app, you can embed the entire Science Gateway as a Facebook application. And if you are authorized with your social credentials, you can single sign on directly through the portal, and you are directly logged in, and you can submit your applications. At the level of the interaction with the grid infrastructure, we are using the GSI, the grid security infrastructure. We are using X509 certificates, but users do not see them, in the sense that to interact with the infrastructure we have robot certificates, but users just need to have a federated identity credential to access, or even social credentials to access the infrastructure. So there is a completely decoupled from the complexity of the grid security infrastructure from the needs of the user to access the infrastructure.
Thank you very much.
You're very welcome.
Excellent. That was really good.